Da, 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 da. The Group 1 Engineering Math. Hello, Assalamualaikum. My name is Wano Aizad bin Wano KAIZA. We are from Group 1 in subject Engineering Mathematics, BF 20903. Today, my friend and I are going to present about the application of engineering mathematics in civil engineering area. This is our fellow member from Group 1. We present myself, Wano Aizad bin Wano KAIZA, as a leader from this team. Muhammad AIMAN MARWAN bin ZULKEPLI, DANIA binti ISHAK, IRFAN HAZMI bin Muhammad ASRAF, and HAFIZ IKHWAN bin ZARIN. This is the content that we will present in our video. The first one is introduction, literature review, methodology, calculation, result and discussion, and lastly conclusion.
Hi, hi. Assalamualaikum dan selamat sejahtera. My name is IRFAN HAZMI bin Muhammad ASRAF. My matric number is CF250118. I will start with the introductions. For stormwater management is an important aspect of civil engineering because it helps prevent flooding, property damage, and safety hazard caused by heavy rainfall. So, at detention pago, there are many impervious surface such as roads, parking areas, and building roof. These surfaces do not allow rainwater to infiltrate into the ground, causing a larger amount of surface runoff during rainfall events. In this project, engineering mathematics is applied to analyze stormwater runoff, specifically multiple integral applications are used to estimate the volume of stormwater accumulated within a selected area of the campus. The main purpose of this study is to estimate the amount of stormwater generated at Udesh and Pago. These findings can help support effective drainage system planning and contribute to reducing potential flood risk on campus. For the problem statement, the problem addressed in the study is the generation of large amount of stormwater runoff during heavy rainfall events at Udesh and Pago. When rainfall intensity is high, the volume of runoff can exceed the capacity of the existing drainage system, leading to localized flooding. This can disrupt daily campus activities and may also cause damage to surrounding infrastructure. In addition, estimate the volume of runoff is not simple task because the catchment area has an irregular shape. Without a suitable mathematical method, it is difficult to obtain accurate result. Therefore, multiple integrals are applied in this study to estimate the stormwater volume more accurately. This result can assist engineers in designing a more efficient drainage system and reducing the risk of flooding within the campus area. The slides show the FILA table, which stands for facts, ideas, learning issue, and actions. It helps us organize our study systematically. Under the fact sections, we identify that Utation Pago experienced heavy rainfall during monsoon season, large paved surface, increased runoff generations, and the drainage system has limited capacity. As a result, flooding may occur when the runoff exceeds the drainage capacity. For the other sections, we propose that stormwater volume can be estimated using mathematical models. The catchment area can be represented mathematically, and rainfall intensity play an important role in determining the amount of stormwater generated. Engineering mathematics can also support the design of a more efficient drainage system. In the learning issue sections, we identify several questions that to be addressed, such as how multiple integral can be applied in runoff volume estimations, what factor influence runoff volume, how to formulate the runoff equations, and also how to interpret the calculated result. So finally, under the addition sections, we plan to study the concept of multiple integral review. Um, Multiple integral, review literature related to stormwater management, collect rainfall and area data, and perform calculations to analyze the finding. Overall, the FILA table serves as a guide throughout the project and help ensure that all objectives are achieved systematically. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAFIZ ZARIN, and now I would like to present about our project objective. First thing first, our objective of project to identify the factors affecting stormwater runoff generation at UTH and Pagoh. Next, to develop a mathematical model for estimating stormwater value using multiple integrals. For the third, to calculate the stormwater runoff volume for a selected area within UTH and Pagoh. And lastly, to analyze the implication of the calculated runoff volume on drainage system performance.
Assalamualaikum and hi. My name is MOHAMMAD and MARWAN bin ZULKEPLI. My matrix number is CF250036. So I began my presentation with literature review. Based on previous studies, stormwater runoff occurs when rainfall exceeds the soil's infiltration capacity. In urban areas, surface such as roads, parking lots, and roof increase runoff and may cause flooding. Researchers have shown that double integrals are an effective method for estimating runoff volume. Therefore, this method is used on our study to evaluate stormwater runoff at UTH and Pagoh. Next, I will explain our methodology. First, we identify the problem of stormwater runoff and its impact on flooding. Second, we made several assumptions to simplify the analysis. Third, we developed a mathematical model using engineering mathematics to calculate runoff behavior. Finally, we created a flowchart to show the overall process from data collection to result analysis. This methodology helps us understand and predict stormwater runoff effectively. Okay, next is the first methodology, problem description. This project focused on stormwater runoff in a selected parking area at Itosan Pagoh. The parking area is considered a rectangular catchment area where rainwater flows towards the drainage system during heavy rainfall. The dimensions are 100 meters in length and 60 meters in width, with a rainfall depth of 0.12 meters or 120 millimeters. Next is assumption. To simplify the analysis, we made several assumptions. We assume that rainfall is uniformly distributed across the entire area. All rainfall becomes surface runoff, no infiltration occurs, the surface is flat, and the rainfall depth remains constant throughout the area. Next is the mathematical model. We define the rainfall depth HXY as 0.12 meters because the rainfall is uniform. Then we use a double integral to calculate the total stormwater volume over the catchment area. Next, this flowchart shows the steps of our study. We start by identifying the catchment area and collecting the required data. Next, we develop the mathematical model and perform the double integral calculation. Then, we verify the results, analyze the runoff volume, and finally draw the conclusion.
Then we go into the calculation. For the first calculation step, we determine the total catchment area selected in this study. The selected area is parking area at the UTH Pagoh and it simplifies as a rectangular surface. Based on the given dimension, the length of the area is 100 meters and the width is 60 meters. To calculate the area, we apply the basic area equation. Area equation length multiply the width. Therefore, the total catchment area is equal to 100 multiplied by 60, which gives 6,000 square meters. This value represent the total surface area that receive rainfall contribute to stormwater runoff generation. For the second calculation step, we apply the concept of double integration to estimate the stormwater runoff volume generated from the selected catchment area. Based on the methodology, assumption rainfall was considered uniform distributed. through the entire surface. Therefore, the range function is h of x and y is treated as a constant value equal to 0.12 meters. Next, the integration boundaries were determined according to the dimension of the catchment area. The x direction represents the length ranging from 0 to 100 meters, while the y direction represents the width ranging from 0 to 60 meters. After defining the function and boundaries, the double integration equation was established to calculate the total storm water volume over the selected area. After establishing the mathematical model, the integration process was carried out. First integration was performed with respect to y, which represents the accumulation of rainwater across the width of catchment area. Then the result was integrated with respect to x to determine the total accumulated volume across the entire surface. By completing both stages of integration, the final stormwater runoff volume obtained was 720 cubic meters. The value represents the estimated amount of the water generated from the selected parking area during the heavy rainfall event. Then we going to the step 3, which is verification. For the final calculation step, verification was carried out to confirm the accuracy of the double integration result. A direct volume formula was used by multiplying the catchment area with rainfall depth. Volume equal area multiply the rainfall depth. Subtraction the volume becomes 6000 multiplied by 0.12, which also produces 720 cubic meters. Since both methods produce the same value, the verification that the mathematical model and integration process are connect and consistent. This means approximately 220,000 liters of stormwater may be generated during the heavy rainfall event with the selected area.
Elaborate about result. Based on our calculation using the double integral method, the total stormwater runoff volume is 720 cubic meters, which is equivalent to about 720,000 liters of water. The calculation was carried out for a catchment area of 100 meters by 60 meters with a rainfall depth of 120 millimeters. To verify the result, we also used the direct volume formula, which gave the same value of 720 cubic meters. This confirms that our calculation is accurate and reliable. The result shows the amount of runoff that can be generated during a rainfall event and emphasizes the importance of proper drainage system planning. Overall, this project demonstrates how double integration can be applied to solve real engineering problems.
Next, we will move for the discussion. For the discussion of our project, the 720 meter cube runoff volume indicates heavy rainfall could exceed the existing drainage capacity, leading to localized flooding. To mitigate this, measures like enlarging drains, constructing a detention ponds, using permeable pavements, and conducting regular maintenance should be implemented. Among these, combining a detention pond with regular maintenance is the most effective approach. The pond temporarily stores excess water to minimize flood risk, improving stormwater management efficiency at UTHM Pagu.
In conclusion, this study successfully applied engineering mathematics concepts, specifically double integrals, to estimate stormwater runoff volume at UTHM Pagu. Based on a catchment area of 100 meters by 60 meters and a rainfall depth of 0.12 meters. The calculated runoff volume was 720 cubic meters, or approximately 720,000 liters. The results shows that double integrals are an effective method for calculating stormwater volume in civil engineering applications. This estimation is important for evaluating drainage system performance and helping to reduce flood risk. Although some simplifying assumptions were made, the study demonstrates how mathematical concepts can be applied to solve real engineering problems. Therefore, all objectives of this study were successfully achieved. That's all from us. Thank you.